Hi there. Hope you can hear me right. Okay. Hi, Emanuel. I'm a principal engineer at Infobip, and today I'm gonna take you through a journey on how to create a Copilot for UI-based chatbot builders. And so this is not necessarily just like a success story. It's a lessons learned story of what worked, what didn't work, and like, okay, what can we do better in a process like this and similar kind of processes. Okay, but when I say, okay, Copilot, so what does it even mean? So Copilot is now like a generic term of some kind of functionality which uses large language models to translate a natural language of users into some kind of meaningful action. And this is what we saw last, and like this year, like a trend of solutions to have this kind of like an AI assistant functionality. And of course, like if you think about it, there are many examples that you already know. So, for instance, like GitHub Copilot, like generates code when you're developing. Midjourney generates images. Microsoft has its Copilot for Office and also for Windows. And this is something that companies and like the different solutions try to get like much more. This, let's say, this current trend. So, okay, so how would you now approach it? Like, let's say you have your own software and you want to build your own Copilot for whatever now your domain-specific solution does. So I found like this is one, I think, nice research paper that I read, which nicely summarizes like all the steps and highlights like the most important things that you need to take into consideration when you're going through that process. So it like shows like you have to understand the business scenario, how do you get the data to train your Copilot, how to evaluate it, what to do, and what's on. So basically now I know. You can go read that paper, and basically I would say this talk is then obsolete. Like my job is finished, and you can all go home. Yeah, I'm not lucky enough for that. But yeah, okay, so this is actually what we did at Infobip. So we looked at that and said, okay, we want to like go through that process and see like how to build our own Copilot. So one of the products in Infobip that we have is to build chatbots, so like within a UI. So what you see like on the right, I think, yeah, this is your right side. You see like those visual elements which you could then drag and drop to the middle part, and with that you can create your workflow, and then like this is the logic how the chatbot should behave. And with this, like, this works fine. This works great. You can build your chatbot in WhatsApp, some other channel, and this is going to work. It's going to send a message, call an API, do some logic, whatever. But what we wanted to do is now, okay, how can we like build upon that and say, hey, let's give our users the option that they should like write some meaningful input, like tell us like what kind of like chatbot they want to do, and then poof, magic, like it's gonna create something. So, for example, if we say, okay, if a user types, hey, I want a chatbot which goes like, which gets through WhatsApp some kind of image and goes through my product catalog and finds visually similar products. So hopefully then something like this is going to happen, which maybe like isn't like a final solution, but it's something that bootstraps the process, and then I can finish the chatbot how I like it, or like it's going to be really a nice solution. So this thing on the right side, what you see, this is basically in our backend, our different like code blocks of like the JSON, some kind of JSON structure, domain-specific vocabulary. It's highly like for this piece of software. So because again, it's code, so what we're doing here in the background is code generation. What naturally like comes to our mind, what we can do, hey, okay, let's use OpenAI or from Google Vertex AI and try some prompting techniques like with these commercial LLMs and see, okay, how far can we get to now generate that list of visual elements, which we can then just plug in the code in the backend, and then basically this is basically the workflow of that one chatbot. Okay, and yeah, so this is what we did, and we looked, okay, so let's try some different prompting techniques here to make this. So the first thing that you can do is basically have like zero-shot prompting, where not what you basically do is you describe your problem. You say, okay, we are now creating a dialog for a chatbot. You put your domain-specific information in there, like maybe have like some kind of vocabulary identifiers that have to be generated in that code block, some kind of format, and with that, hopefully, like we're gonna like generate what we want with that input. And this is actually already like where you need to really understand your own domain. Like when you're building a Copilot for your functionality, you have to understand, okay, what are like some requirements that have to be like generated and take into consideration. The next thing that you can do is what we also then tried, like a few-shot prompting, where in addition to all that definition, you add some examples. Say this is some kind of input that the user could put in, and then this is a desired output. And hopefully, like, it's going to generate better, better basically results. The next thing that we also then tried is, okay, in our product, we have some special rules that have to be taken into consideration. So when you saw like these visual elements that are going to be drag and drop, so for instance, like one element maybe like can only appear once. So another element cannot appear before another one. So there are like some domain-specific rules which somehow have to be taken into consideration. So if you write that into prompt, maybe like it's going to work. And the fourth thing that we also then tried is like more sophisticated prompting techniques like chain of thought, where we like introduce like more reasoning steps on like, okay, really to try to understand the input, like how to now perform a specific action, how to select an element, maybe how to end the dialogue, those kind of things. And now, basically, okay, we did a bit of prompt engineering. We think like, okay, we know how to solve now this Copilot problem. And the first thing, okay, so what should we do now? Should we go to production, or we said, okay, let's go maybe test it beforehand to get an idea how good does it perform. And yeah, so this is actually what we did. So we wanted to understand, okay, like when we use like Google's, at that time, Gemini 1.0 Pro and GPT 3.5 Turbo, like which one performs better with respect to those techniques. And we measured two things. Basically, we wanted to know like which model like hallucinates more, and if it hallucinates, like how much, and which one is more accurate. So, and here is also again like this one thing that you need to understand. So when you're building copilots, that like why it's important to understand your domain. In our case, hallucination is something that you define by yourself. For us, it's basically, so we are creating some kind of a JSON format. So we need to validate that output, that it can be parsed to do something with that. We have some like domain-specific vocabulary identifiers that only those can be generated, not some random words, which, hey, we cannot interpret that. And again, like we have to like really understand like those rules like that are enforced in our backend. They have to be also considered there. Else we cannot render it in the UI and nothing's going to be like shown to the user in the end. So those things matter really much, because in the end you're not going to like, your Copilot's not going to generate anything. So what we hear, so with a lot of prompt engineering, like we managed to bring it like to a hallucination of around like 9%, and accuracy in this example is basically a hit rate where we say, okay, like given some kind of input, did we really 100% like exactly predicted or generated what was expected in our experiments? And here one interesting observation is like, okay, for both of those, like Google or this commercial models, we had to use like more sophisticated like chain of thought, basically prompting to get like more or less similar results, that they're like stable when compared to each other. And this basically, and Google in this case was much better. But if we look at this more like simple prompt, for instance, in that case, like OpenAI was here much better. So this like just tells you like really it depends. If your prompt is really sophisticated, like, okay, then maybe it doesn't make much difference what kind of vendor you take. But in our case, we saw, okay, like really we have to have this more sophisticated prompt in order to like, it shouldn't matter. Okay, so now basically we did this. So we know, okay, we can like, this is like our performance with respect to hallucinations and accuracy, and we can go to production. And we asked ourselves the question, okay, but like, is this enough? Like, should we maybe, like, can we do better? I mean, the answer here may be like, okay, we don't need to be better. This is enough. Let's go to production and already like give this to our users. But like in our case, we wanted really to find out, okay, how much more improvement like can we get? Maybe can we get really like less hallucinations or something else? And in our case, this is exactly what we did. So we wanted to see, okay, what would happen if we really adapt large language models to our domain, to our own data set, to our own data that we have. So what we then did is, okay, we said, okay, there's like GPT 3.5, which is a really large model. Let's try to train it with our own data and see if it's getting better. And at that time, we also like picked some open source variants like Mistral, Llama, 3 billion parameters in order to see, okay, maybe like, do we really need this like commercially more maybe like expensive model, or maybe we can do it with some open source variant which is like smaller or something, and then we're gonna basically save some resources. And this is also what we wanted to find out, like, does it really for this kind of Copilot functionality, depending on your domain, does it really make a difference? Does it need to be like this largest model? Maybe like something smaller can already like, it's enough for your task. And then you don't need to think about, okay, we need a A100 or really a huge GPU cluster or something to really serve those kind of models. Okay, so how would you approach now with training those kind of like LLMs with your own data? So one thing that you need to do, like again, for your own domain, to define what's the input and the output. So in our case, we're building, as you remember, generating dialogues for a chatbot builder. So we have to have an input, which are user queries. So what would a user write? Hey, I know, give me a chatbot for some kind of financial institution, banking, do something else, for healthcare. And the output would be, again, like those code blocks, a sequence of elements in some kind of maybe like JSON format, which is, again, something domain-specific for your own task. And okay, so, and you need a lot of data, actually, a lot of amounts of those data in order to really make a difference and basically train such large language models. So we then looked at the data and saw, okay, but we don't have it. So at this point, we want to see, okay, I mean, we have like those like examples of like dialogues, how a chatbot behaves, but we don't know what a user would ask. Like, how would a user behave now on the platform and ask those questions, hey, give me a chatbot which does something. So one option at this point, we could cry and go home and now stop the whole thing. But yeah, we didn't do that. We cried a little bit, maybe that. But the thing that you can actually do is you can synthetically generate those kind of data. So, and this is, I would say, a really cool feature of large language models. I mean, they have like the term large in them. So this basically means they were trained on a lot of data, which, and with a lot of knowledge, which is now somewhere hidden in it. And the hypothesis is here that, okay, you can actually, and this has been shown already a few times, you can extract that knowledge from those models, and especially like the bigger ones, the GPT-4, like the larger the better, so you can extract even more data and more like meaningful data out of it. So what we did, we like cleaned like our chatbot dialogues, we standardized, anonymized, removed unnecessary stuff, and did a bit of prompt engineering to really like synthetically generate how like those user queries would look like. And this is just like one example of how you could do it. So this wasn't like the final prompt, but you would then start really to think about, okay, how for my domain can I now synthetically generate the data? But it's possible. And this is shown, at least in our experiments, that it really can help with making now a Copilot. Okay, so once we did, so now we basically had our own data. So now we wanted actually to fine-tune those models. So how would you approach it? So if you think about large language models, so these are basically like huge neural networks with a bunch of matrices. So usually if you train a model, this is like a complex reinforcement learning pipeline, and it takes a lot of resources, GPU capabilities, a lot of data, even more than we had. And so this would also take a lot of time. But the cool thing is like there are like different techniques that you can use actually to train it much faster and actually get to your result. So one of the techniques is basically low-rec adaptation, where instead of like training this whole model, you just have two matrices, which you train now on your like subset of data, which is now, at least in our case, specialized for now those Copilot or chatbot building. So this is much faster, you don't need that much GPU. And basically the idea is that now those two matrices are basically steering the large language model like into the direction of the kind of text that should be generated. And this has shown to work. So, and the cool thing is about, so there are many different frameworks out there that you can use. For instance, you can go to GitHub from Hugging Face, parameter efficient fine-tuning framework you can use, or you can, for instance, like download LLM Studio. You can deploy it on your GPU server. You upload basically a CSV file, which is similar to like this input-output, what I showed you before, and you train a model. You can download it and deploy it somewhere. And this works, and it's actually not now that hard. You can go now, like in the next break, and do it by yourself. And so this again, so we did this. We tried now like to fine-tune all the open source LLMs as well as the commercial one, GPT, and to see, okay, now are we now getting any better with now those fine-tuned variants when we create, again, like those like workflows for a chatbot, giving us some kind of input. And this was like, for me, like really interesting once I saw the results here that we got. So if you remember, so we got like, with a lot of prompt engineering and sophisticated prompts, we like hallucinated still like almost like 9% of the time. But here with the fine-tuned models, we reduced the hallucination to almost like 0.04%, which is like really significantly lower. And also like, if you think about accuracy, so this hit rate, where we really like managed to generate exactly what we wanted. So we managed to increase it from those like what 5.41%, which was from Google, to 18 to 26% of the times. Given here, Mistral was the most accurate one, but had like the biggest amount of hallucinations because like it needed a bit more data, what we found out. But here, I think for me, at least like what was one really interesting finding, if you see like the models are like sorted from like the smallest one to the biggest one, given like the amount of parameters. And here we saw that basically this shared llama, so this is this was done by a research group from Princeton. So basically they used the llama 2, 7 billion parameters, they pruned it to be more efficient and have a much, basically need much less resources. So in that case, we used this really the smallest LLM that we had in our experiments and achieved, given the hallucinations, really like the best results and really a good accuracy. And this is especially significant if you think about later when you're going to deploy it. So this just tells us, okay, you don't always need like really the biggest player on the block, or again, like some maybe like smaller model can also like do the job for you. And once you now train your model, again, like you have like the text generation framework from Hugging Face, you can basically use it to serve that on your GPU machine. So this is just an example. We trained our models with LM Studio. Once we downloaded, this is a one-liner how you can run your model. For Mistral, we had to use Llama CPP to convert it to another format. But again, like this isn't like too hard. But here is again like this, for me at least, the most interesting part is that this smallest model, which had the best performance in terms of like hallucinations, like had the lowest amount of like VRAM that it used for our GPUs. So then, if we think about, okay, now we put it production and we want to maybe scale it like with tools like VLLM to achieve a higher throughput, this is much better. I don't need a really huge GPU. This already like can do my job. So I basically save money and get still the same amount of performance. Okay, so yeah, this is basically what we did. And now we were quite some like sure, okay, now we know how much we can get out of our models. I mean, sure, we can maybe also like now use newer models, Llama 3, Grok from Twitter. We can use maybe the latest now GPT variant. But besides that, we also thought about, okay, let's put it in production. Let's test it with users and see like, is now like this AI, this like ML model, did we solve everything? Now the Copilot is the best, perfect thing ever. And this is also like what we did. So we tested our like Copilot with with different users and really wanted to see like how do they behave. And this is like one interesting finding that we saw. So when people were like testing our Copilot, that they could pick like what kind of model could they choose, like a GPT fine-tuned, maybe a prompt baseline. So they could basically pick what kind of model. And also they could like set the temperature. And 90% of the users basically stuck to the default model. They didn't even like open this drop down. They just like, okay, this is right, and I'm just going to use it. And also for the temperature, like similar, like 87% of the users, they basically just preferred what you have given. And when they like didn't get a satisfactory result or some kind of error, they just rephrase the question. So this tells us we have this position bias. So the first thing in this drop-down list is going to be selected either way. People don't just care. They're lazy. I mean, I'm also like this. I'm just not going to look at it. I'm just going to pick it. So this basically tells us what we need to do from ourselves when we now deploy such Copilot. We have to maybe like reduce this burden to the user. So we need to maybe implement some kind of like online model selection algorithm, for instance, like multi-arm bandits, to achieve this better usability. So multi-arm bandits that's not like something new. That's well known. Basically, what we would learn for each, let's say, large language model, some kind of probability that it should be the best one to solve this specific input. And this is something that basically can be learned. Why this is useful is because maybe like, I don't know, because of data drift, some model gets worse over time, so the bandit would then recognize, okay, now pick another model, or maybe just giving a different user input. Maybe, again, one large language model isn't the best suited one to solve that task, and it will basically explore and find out which one to choose. But either way, this is something that shouldn't maybe be led to the user. This is something that we have to solve beforehand, that we reduce that burden to the user. Another thing is, okay, we want to maybe still like improve more like this, how does the Copilot perform? That's even better, that user acceptance is higher. So if you're basically tracking user feedback, and especially if you're letting your users say, okay, this is really good or this is bad, am I satisfied or not? What you can basically do is incorporate that feedback into additionally tune your large language models. So if you think about how like GPT was trained with like a complex reinforcement learning pipeline with a bunch of data. So now one of the recent trends is like this like human-aware loss functions. So one is from this like paper from Kahneman-Tversky, where basically they showed, okay, you can additionally like have an optimization function where if you have like this binary feedback, this was good, this was not good, and especially if the data is imbalanced, so meaning like, okay, you have more negative feedback than positive. So, I mean, like, people are more likely to say, oh, this is crap, and you're not going to go after this talk and tell me, hey, this was really good. You're going to probably say more if it was bad, something like this. So if you have this kind of data, basically, like this KT optimization is something that you can use to even like more steer the Copilot into, or the LLM into the direction that it's more like produces something that the user would expect. And again, you don't need like to really dive into that. This is again something that like LLM Studio has built in, so you can just use it. You just need to have those kind of data where you somehow tracked that feedback in your UI. Okay, and the last thing for maybe like this talk, because I said like this is like a lessons learned. What we saw, okay, this user frustration is something that you really need to tackle when you're like providing such kind of a Copilot functionality. So the hallucination is here, I would say, the most important part. So it has to be, I wouldn't say even like almost zero. You shouldn't like have any like errors. You should always like produce something that is somehow meaningful. For instance, you should have at least like a fallback option, like a KNN approach, where you would like, given a user query, maybe you have some kind of like vector database with like successfully generated dialogues or some other caches, where you say, okay, now maybe like I can at least generate something which is meaningful to that query. At least show the user something, because if the users are frustrated, they're just going to give up. They're not going to even like generate the data that you may need later to make that a final and better product. The second thing is that we saw like the need for explainability and the control of the user. So basically, the lack of explanations when like a Copilot doesn't like, it fails, it doesn't generate something meaningful, is really like hinders this user acceptance and like trust to the system. The same thing, like it helps really to show the user like the timeline. Hey, you typed this, you generated this, and this then also like the user then more likely to use the Copilot. And one of the things is like, as I said, like even if you solve this machine learning problem, that's not all. So UX and UI design plays here a crucial role. How you're going to like show that to your users and integrate it into your system. And also, what really makes sense is like splitting the tasks. So this goes into this direction of like Llama agents, where you would like before you maybe like call now your specialized LLM. First, like figure out, okay, is it maybe like a generation task to generate those things, or maybe like the user just ask a question. So maybe it makes more sense once you provide those Copilot functionality, like split it into multiple experts rather than have like one silver bullet, because probably it's not going to solve everything. And one thing that we also like, what we saw is like you should handle short queries. So I mean, people are lazy. I myself also like, I'm just going to write maybe a few sentences, and I'm hopefully like the AI is going to figure out. So one of the techniques that you can use, basically this like query expansion, where you could just like call an LLM to like try to figure out, given some context, hey, maybe like this is like this expanded actually input query. This is what the user has actually wanted to write. And then this is the input again to your fine-tuned LLM to generate the final workflow, which in the end will result in a functioning chatbot, which you then deploy on WhatsApp or somewhere else. Okay, so that's it for me. I hopefully like you don't need to Google those links. The slides are on my webpage if you want to look at it. I think we have some time for questions, or if not, we can later like stop me somewhere outside. Thanks.